Hello, everybody. This is Eike from Accensors, and a warm welcome to our second webinar after the summer break. And today we want to go a little bit deeper in the topic of biosensor, what is possible and what will be possible in the future. And I would like to explain you a little bit of our new sensor portfolio, especially in the field of biosensors, and why it is really needful that we developed this, and what are the problems and what are our solutions about it. Yeah, so accensors, our motto, our slogan is the new kind of sensors. And especially today, we want to go a little bit deeper in biosensor stickers. So from research to series production, and this is exactly where we currently stand. So in the scale-up period, we want to scale up our production. Currently, we have a lab production with a capability of 4,000 sensors a day, and we want to scale it up. And we want also get in touch with you, maybe with you as a potential customer, and discuss the pros and also the cons of the product, and maybe what should be next parameters we want to create, we want to develop, and test it also together. And let's go a little bit deeper. And we start with a problem, and there is a big why. So why we do this. And we do this because biosensors, and especially here we are talking about the functionalized biosensor electrode, are not commercial available. So that means if somebody needs a biosensor for his product, and you see this picture on the right side, it is like the Corona COVID test, that could be also a digital sensor test in the future. And if you want to develop product with the biosensors, you have often to develop and to disassemble this biosensor by yourself. And many customers have not the know-how or not the capability, or also no clue about it, how to create this kind of biosensors. And this is exactly where we want to step in. So we want to create prefabricated components, and there must be easy to integrate it into the application, and also in the customer products. If you imagine you are an electronic developer in a diagnostic company, and the strategy of the diagnostic company is for the future to develop or to deliver more deeper insights, for example, blood parameters or something. And so you as a developing engineer have the challenge to create the first prototype of a product, and you should integrate in I don't know, in a watch, or in a catheter or something, a lactate and also a glucose sensor, because these are two parameters your colleague mentioned that they are really essential and significant for developed or deliver more deeper insights. And so no problem. Then I, as a developing engineer, electronical engineer, I ordered a few sensors from my electronic supplier and built up the first prototype board. And exactly here we see the problem. If you go to DigiKey is one of the largest electronic supplier for components, and you go especially in the field of sensors, you will find a lot of different sensors from temperature, pressure, conductivity, but you will not find a lactate sensor or a glucose sensor. And so now you, as a developing engineer, have a big problem, because how and where you get these essential sensors, because you need it, because without this both parameter you cannot create the first prototype of this deeper inside product. And exactly this is the open spot we address by accensors to bring a portfolio of biosensors absolutely directly available on the market and also ready to use. And this is our solution. So we call it SMD Surface Mounted Device Foilsensors. And it is a standard available sensor portfolio for different parameters. So that will be not only biosensors, so for lactate or glucose, there will be also electrochemical sensors available for pH, potassium, sodium, and also physical sensors, because if you want to create a multi-parametric sensor array, you often want also to integrate physical parameters like temperature or pressure or conductivity. And we want to bring a lot of opportunities to our customers. So it should be as easy as possible to assemble your own sensor system. And this is why we decide to build it in a sticker layout. So this means you have the sensor, you take it away from a liner, and you push the sticker on your periphery system, on your flex PCB, on your PCB board, or also on your printed electronic. And that's all. You don't need more conductivity processes like soldering or welding, because with this sticking effect and with the pressure, a little bit stick pressure, we create the mechanical fixation and also the electrical connection. And this gave us and you as a customer's opportunity to reduce a lot of developing time, because the sensors are available. You can order it, and in the best case, in 2 or 3 or 4 days, you have the sensors in your post box, and you can open it and you can use the sensor. And this means the developing time will be reduced, and of course the market entry cost, because you don't need to develop a special customized sensor solution. You could use our standard portfolio and go with the standard portfolio into your serial production. Where we see from accensors our focus. So a little bit to explain what is possible with biosensors and where we see the biggest match. We do a really big market research on the relevant application fields. And in total, there was over 13 branch and market fields. And here you see, for example, these fields where we see the biggest impact for our sensor technology. So, for example, smart patch or medical sensors for non or short time invasive. And I also added here the automotive sector, because for some people are more from the industrial side, that will be explained a little bit better. Where is our focus area regarding to long time measurement applications. One example, go a little bit deeper inside. Here you see the market analysis of the smart patch, so wearable smart patch solutions where you can stick the patch on your skin, on your body. And we analyzed a field, and the field means how long should be or could be the sensor in use, so time of use, and what are the expected measurement accuracy of sensors in the field of smart patch applications. And here you see that the field, the red field, is starting by nearly 12 hours. So this means if you because if you need a smart patch, you want to wear it, and you want to wear it for a longer time. So starting a half a day, so 20 hours, up to maybe 3 weeks. After 3 weeks, I guess you want to change your patch and take a new one. And so this is the field of the time of use from several hours, so more than 12 hours, up to 3 weeks. And from the accuracy, we have a continuous monitoring because you every time wear this smart patch, and you could every time create data from it. And so you see changes in the value really, really fast. So this means you don't need a really accurate measurement. You often see a total behavior of a parameter. What is going on with this parameter in the last days or something. So this means that the accuracy of a measurement is not really high end. So we don't need to go for a tolerance of plus minus 0.1. We have to be a little bit better than plus minus 1% of the tolerance of the sensors. And this analyzes, and also what are needed other requirements for the sensor. Must it be flexible, or must it be consumable? Must it be hemocompatible? We put together, and we do this analysis of every of these market fields, and put the areas together in one overview. And this is the result of this market research. And this is also where we decide, okay, this is from Accensor side, our focus area, where we want to create sensor solutions. And this means our sensors are perfect for a time of use from a few minutes up to 4 weeks, so 1 month. So this is where we want to create solutions and a portfolio of biosensors, of ion selective sensors. Because the physical sensors you could also use longer period. And remember, I explained a little bit that I also added the automotive sector, because the automotive sector is the blue column there, the blue field. Because if you want to integrate a sensor in an automotive application, it must be time of use 20-25 years. And so this is not our focus with the biosensors and our electrochemical sensors. We are focused on a few minutes up to 1 month, 4 weeks, and with the accuracy a little bit better than plus minus 1%. But it needs often consumables. So we're talking about consumable sensors, easy to integrate it, maybe in the future, and we're working on it with recycling or refreshing concepts. One example, also what was from the other side, from the production side, the idea behind the SMD Foilsensors and especially the biosensors. Here you see a pH sensor system. pH sensor system is built up from 2 electrodes. The silver electrode is the reference electrode, and the gray or black electrode is the pH sensitive electrode. And you do a amperometric measurement between both electrodes, because the pH sensitive electrode will change the potential if the pH value is changing in the medium, and the reference electrode will not change the potential, because it's a stable potential in this liquid. And if you produce some kind of sensor system, because we're talking about 2 electrodes in a production process, that is not so trivial, because you need for the sintering process of the ion selective membrane, for example, a UV curing process. But if you have before finished the reference electrode, and you go with this finished reference electrode because it's on the same stripe into the last process for finished pH electrode under UV light, you will damage the reference electrode. And this means you have requirements how to manufacture a sensor system from different elements. And if we are talking about biosensors, we have a biological component over the electrode. So like an antibody or enzyme or other functional surface. And this is not possible to go in heat process, in a UV curing process, because then you will damage the finished sensors. And so the idea was, okay, how we could bring these restrictions in the manufacturing process a little bit, or make it a little bit easier. And if you look to the electronic manufacturing technology, you see that there is PCBs. So there will be PCB created with all the tracks on it. And after this, you have a pick and place process where you have rolls on a pick and place machine with resistors, with microcontrollers and diodes and some stuff like this. And the pick and place roboter takes the elements and places it on the right position. And after this, you go into a soldering process. But this means that there is also a split between the tracks, so the periphery electronic, all the conductors, and the real electronic elements. And so we see that this idea is also a perfect solution for us, how we could create a portfolio of different sensors, but give our customers the opportunity to puzzle her own sensor system together without the restrictions in the all-in-one manufacturing process. And so, yeah, we would like to enable many partners and customers to use our sensors in their system and in their products. And this is the same sensor stripe, the pH sensor stripe I shown you before. And here you see it in the technology of SMD Foilsensors. So this means we have 2 tracks. They go from the PET side. The PET is connected to the measurement electronic to the top of the stripe. And here are one open area, and on this open area we will place by a pick and place process, for example, the reference electrode. And the blue sticker, the blue SMD foil sticker, is the pH sensitive electrode. So that means we take this electrode sticker, placed it on the periphery board with a little bit pressure, and that's all. Then we have a mechanical fixation and we have electronical connection. And of course, we have the possibility later to bring it into a recycle or into a refreshing process. And this could be a tryout kit. So this is something in our mind that is not real currently, but that is not a big deal. If you want to measure it in a tube system, for example, we could bring our sensor stripe you seen before, where you can puzzle your sensor elements you want to have, for example, lactate or glucose or troponin or creatinine or sodium or something on the stripe, and embedded this stripe in a fluid housing with Lure lock adapters, and you can connect it to the tubes, and then you have the possibility to measure it in a flow system, these kind of parameters you want to have. Let's go back to the SMD Foilsensor concept. So how it looks like if you go a little bit deeper on this sticker and have a look on the sticker, there are like a multi-layer assembling sticker. So we have first a base film here in yellow. It is a medium adhesive underlayer, so a little bit sticky, but not really sticky. We need it for the production processes. And on this basis film, we print the electrodes, and we have an open areal on the right corner, of the down part, and this is where we integrate the E-tape. E-tape for the electronical connection, and so this means one part of the E-tape is over the base foil, and one part of the E-tape is over a free-cutted areal of the base foil, so not on the base foil. And of course, if we produce this kind of sensors, the whole sensors are, before you peel it off, on liner, because we want to protect and we want to have it in a fixed position. It's sticked on a liner, but you can peel it off and then you stick it to your application. And to cover the base foil and also the E-tape, we used a cover foil. And this cover foil is this green one, I guess, or maybe gray one, green-gray one. And this cover foil has the task to build up the isolation. So it makes a housing of the E-tape in the base foil. But of course, in the middle, where the electrode is, there is a hole. So there is an open area, because our functionalized electrode, and that could be a ion selective electrode, that could be a bioelectrode, enzyme-based, antibody-based, is open to the measurement medium, and it needs also directly contact. And the cover foil have the isolation task, and also to bringing the mechanical fixation on the periphery surface. So this means this framework you see, this frame is for the mechanical adhesion on the periphery foil. And of course, here we used a biocompatibility material and also biocompatibility adhesive. Then you have no problem about medical use or biotech use. A little bit of outlook, and not only outlook, also what is in the near future available. So I told you that we will create our SMD Foilsensor portfolio in 3 groups. Group 1 is more or less standard. It's the physical sensors like temperature, moisture, pressure, conductivity, impedance, some stuff like this. Then the biochemical sensors. So we have finished so far troponin. We're working on lactate, creatinine, urea, and NT-proBNP that will be ready in the end of this year for first pilot customer tests. And of course, there is a list of many more interested parameters. But here we have to investigate a little bit with the potential customers what parameter will be the next in the development. And the ion selective sensors, for example, pH, sodium, kalium, or magnesium, are also available. And we will add a few, I guess 1 or 3 more parameters also in the next weeks here to bring it to first pilot customer field test. If we go a little bit deeper in the layout of the foil sensor, so this is our first layout for all these biosensors and ion selective sensors. So every ion selective sensor, pH, sodium, potassium, or every biosensors will have the same diameters. So this means that also for the pick and place process, often a full automative process, you can use the same grapper to place the sensors. And the outer diameters are 5.6 to 7.6. And you see also, if you look at the back drawing, that we need like a pad, a periphery pad, in these diameters of 1.5 to 1.6. So this is the pad size we need at the periphery layout, where we want to connect via this E-tape our biosensor or ion selective electrode. In the future, we will be working on more miniaturization of these sensors, but currently we guess for first rollout of this new product line, that is a great size. It is not too small, not too large, and you could really good handle it also for first manual processes, manual sticking processes. So this is fine, and we will build our first product line exactly on these diameters. If we go, for example, on the temperature sensor, because temperature is the most measured parameter in the world, and we also need a temperature sensor in the SMD Foilsensor portfolio. Many parameters are in directly correlation with the temperature. So that means if you want to measure really accurate the pH value, you need a temperature sensor for doing a temperature compensation. And by the temperature, the layout, the outer dimensions are in the absolutely same parameters, so 7.6 to 5.6. But we need 2 pads, so 2 tracks with a pad, because that is a resistant measurement, and not only 1 pad under this temperature sticker. We need here 2 pads under this temperature sticker. There's one point we will also bring on the table. The major or the main focus areas are in really high regulated branches and market like medtech or biotech, and here you often need 100% traceability. And for this and for the future means for bring our sensor element as a calibration-free element to our customers. We put a small QR code on every sensor element, and there will be a database, online-based database, where you could read out all the relevant traceability ID data from this sensor, and also in the future the calibration data. So this means if we have a little bit inter-individuality difference in these sensors, and that will be the case also in mass production, but not every sensor element is exactly the same, and you want to have a high accuracy, we will give you this in-house created calibration data for this sensor, so that it is really possible to take the sensor, stick it, and then use it, and not do a 1 or 2 time calibration. Here's one example from a currently project. We could not talk about the customer, but that is a periphery electronic or periphery printed board, where you see the accensors logo, and it is for a smart patch. And we printed these tracks on a TPU film. TPU is a little bit stretchable and also really nice for directly contact to the skin. And we placed on the bottom area 3 sensor elements: a sodium electrode, a reference electrode, and a temperature sensor, because this smart patch is a sodium balancing patch. So this means the use case is 1 of 5 getting older people and go to the first response doctor and say, hey, Mr. Doctor, maybe I get a demence because I could not remember on Saturday evening or something. They don't have an upcoming dementia. They have only a sodium or 2 less sodium molecules in the body. And often these getting older people will get or create a situation where the doctor said, okay, you get dementia and I will give you some substance against dementia, and that is not right, not a good way. Yeah, we want to create a smart patch solution that the first response doctor could say, okay, we will double check it and we will stick you a smart patch on your arm, and please wear it 1 week, and after 1 week we will have a look on your sodium balance, and maybe we see that there is not an upcoming dementia. Maybe we have to talk a little bit on your food manual, because we have to change a little bit of this. And this is a picture of the process. The easy way is we have a vacuum grabber, and we could take the sensors and place it on the smart patch TPU film, and the sensors will become on the roll or on a stripe. And here, maybe if you look to the camera, this is one of the reels, and here you see that is the liner, and on the liner the sensors are sticked, and then you have this peel off station where the liner stripe going down and the sensor stripe or the sensor sticker went to a special area, and from this area we could use, or you could get it with a standard vacuum grabber and take it and place it and stick it, and then it's fine from all the connection, from the electronic connection, from the mechanical fixation. And in the future, that was the last application picture with that is one of the sodium patches. So if you wear it, you have the possibility to see your sodium level in sweat on your cell phone, and you could measure or have a retrospective view of the last week, and you maybe see that there's something wrong with your lifestyle, food lifestyle. Yeah, so come to the end, why we have developed this product portfolio to ensure that our customers, and that are hopefully you, have access to ready and immediately available and easy to integrated economical, attractive, flat, flexible, and miniaturized sensors, and of course we will be miniaturized in the future a little bit more. And yeah, we want our customers to be able to design and to realize multi-parametric sensor system independently and freely. And yeah, we could bring these sensor elements as a standard portfolio on the market, and hopefully you are happy with this sensor and the sensors element, and you will use it in your application. And yeah, our motivation and our vision is we want to do it for live announcing sensors. So the field we also at the beginning looked into the market research. We have identified our medical, our agriculture, environmental over monitoring, biotech, and also some applications in the industry field. And but every of our sensors have the opportunity to yeah, be live announcing. And one statement from my side, the sensor integration is the key of making products smart and more effective and efficient, and so that they can support us in our everyday lives. And that not only means medical, that means also other branches. But if you know what's happened in your process, you could control it and yeah, make it on a next level, because you exactly know what's happened and you could yeah, control it. Yeah, and one of the last slides, we are open for new customer, pilot customers, and we want to test our sensor with you, because we could imagine a lot of applications, but we are not the product owner. We need yeah, our customers also to investigate our technology and get feedback, and because feedback is really important for us to maybe do the future or further development of the sensors. And yeah, we will be happy if you want to be one of these pilot customers and want to try out these sensors. And if you're interested, please let us know. I guess we have also one launch plot here, so that you could vote here, or you get in contact after this webinar in the next days, weeks. So we are open. We are searching for pilot customer to yeah, get the first feedback really from people we want to bring on the next level, because they need our sensor solutions and want with our sensor solutions more insight and more solutions for the end customers. Yeah, thank you very much. I guess it was really short and quick insight what we do, what we have done so far, what we want to do in the future. And yeah, now we are open for some questions. Please write it into the Q&A section, and yeah, hopefully we could answer them. There is one question regarding to the standard shelf life of the sensors, and the, or is it generally, or is it specific on the parameters? It is specific on the parameters, and it's also specific sometimes on your application. If we go into ion selective sensors, the limited factor of a good ion selective measurement system is the reference electrode. If the reference electrode gives you a stable potential, you could measure it a long time. If the measurement electrode, because there is an outbleeding effect, if the reference electrode don't give you a stable potential, you will not measure really accuracy value. And so it depends also if you place, for example, ion selective measurement system, reference electrode, and ion selective electrode in a tank with absolutely still medium, or with medium in motion, then you have the outbleeding effect is higher by medium in motion as in a not flowing medium. So it's the answer is yes. The shelf life depends on the parameter, and it depends also on the integration environment of the sensor in your application. But we will be also create for the same parameters different sensor solutions. So this means sometimes you need a quick sensor. So you put a blood drop on the sensor and you want to get immediately a result. So you need a really, really short setup time. But the shelf life or the measurement time is not so important. And sometimes you have a long process, biofermentation process or something, and so the setup time could be 6 or 8 hours. It doesn't matter, but you want to measure it over 4 weeks. And this could be the same parameter you want to measure, but the time of use is totally different from the application. And if you're talking about or asked about storage conditions, that will be also a limited factor. So it will be not possible to use sensor elements that are older than 6 months. But if we are coming to a situation where we are talking about a Syrian product or something, we will definitely do a just-in-time production. But if you integrate the sensor element in your product, that will be also a limited time of storage, because the sensors are not for every time storage conditions. And there is another question. Production clean room. Currently not. Currently it is in a lab environment. It will be in the near future. If I told near future, that will be next year, not this year, but next year. But it will be not really a clean room. It will be more like a little bit dirtier than a clean room 100,000. So from the ISO standard. So it will be not really a clean room, because we don't need really a clean room, because the sensors will be get into a stabilization process if they are integrated in the application. And is cell culture one of our targets? Yes, of course. We have customers, we have applications where the sensors are in cell culture. So yes, definitely yes. And there's one question: do you have a plan for development of continuous monitoring of cortisol from thread? The short answer is yes, we're working on it. If we are talking about biosensors, you know that there is a restriction that you have this catcher system. The catcher system is immobilized on the surface of the electrode. And if there is enough molecules to catch, then the sensor is blocked. And also, if the value of cortisol, for example, going down, you will not see it, because every catcher is full and blocked, and you will get the same value. So there are two challenges we're working on. One is to create a method that biosensors is not only possible to measure it in one direction, so in the raise up of the value of the target molecule, also to detect the going down of the value of the target molecule. And for continuous monitoring, if we talk about blood or something, you have problems for hemolyse, hemostase, clotting effects also on the sensor surface. And here we are, I guess at the beginning of the next year, we will present the solution where we have biosensors and also ion selector sensor with an with an open surface to this medium, but we will specially protect them that we have not this clotting and hemolyse and hemostase effect on the surface. And that is one of the elementary points for continuous monitoring. Maybe for this question, not really in sweat, but if you want to measure in blood or something, interstitial fluid. Okay, then 10 minutes before the time, so that is good. I want to do it quick because a lot of information, and I guess if you are interested in our solutions, please let us know. And thank you for being here today, and hopefully it was also for you a little bit interested, and you get a little bit more insight what we do, what is our mindset, what we want to do also in the future. And thank you very much, and hopefully we get in contact, and maybe we see us soon. Thank you very much. Bye bye.